In this video I'm going to talk about Nicomachus theorem. So this is an interesting identity that the sum of the cubes of the first n numbers, first n natural numbers, is equal to the square of the sum of these numbers. So we are going to prove it by induction. So by induction. So first we check the case n equal to 1. So this is very easy. So on the left hand side we see 1 cubed is equal to the on the right hand side we see 1 squared. So this is correct. So now we are going to assume that the identity holds for n, and we are going to prove that it holds also for n plus 1. So assume that holds for n. Okay, let's remove this. So we assume that this holds, and for n, and now we consider for n plus 1. So for n plus 1, so let's start from the right side. So we see that here we have 1 plus 2 plus and so on plus n plus 1. All of this squared. So we are going to expand this as 1 plus n squared plus, so we basically treat it as a sum of two numbers, this one and this one. So plus 2 multiplied by 1 plus n multiplied by n plus 1 plus n plus 1 squared. So now we are going to replace the first term, this one, with the sum of cubes because of our assumption. So this is the same as the right hand side in our assumption, therefore it's equal to this, right? So we write that this is equal to 1 cubed plus so on plus n cubed. Now in the rest of the in the remaining two terms, so we observe that there is a common multiplier n plus 1, so we move it here. Like this, and now we use another well-known identity that basically to find this sum, because it's a sum of an arithmetic progression, right? So it's equal to 1 plus n multiplied by n divided by 2. So when we replace this, we get that so first it's 1 cubed plus so on plus n cubed plus n plus 1. Okay, let's remove this from here. Multiplied by 2 n plus 1 over 2 plus n plus 1. So we see that there is again a common multiplier here and here. We moved outside of the brackets, so now we get so here you see that 2 cancels with 2, right? So what remains is basically n, like this n, right? Plus 1. This is from here. So this is n plus 1 squared multiplied by n plus 1. It's n plus 1 cubed. So what we can even remove the brackets. So it's 1 cubed plus n cubed plus n plus 1 cubed. And this is exactly what we needed. This is the left hand side of the original identity for n plus 1. So this so just to remind again, so we started with this term and we ended with this. This is exactly the identity for n plus 1. So this concludes the proof.